On to another challenge. This one's called pairs of integers from m to n. Implement a function that receives two integers, m and n, and generates a sorted list of pairs a, b, such that m is less than or equal to a, which is less than or equal to b, which is less than or equal to n. So you can see the pairs are bounded between the inclusive range of m to n. The input m will always be smaller than or equal to n. So m is always less than or equal to n. Example, m is 2 and n is 4. Here's your result. You start with the pair 2, 2, 2, 3, 2, 4. And then you can see 4 is sort of the max there, right? And it goes up to 3, 3, 3, 4, and then up to 4, 4. And then finally it's done because 4 is the max, 2 is the min, so they want all pairs within that range. I think that's clear. Go ahead and pause the video and come back when you're ready. These challenges where we're sort of generating sequences seem to be hot lately. So we'll have more opportunity to use the yield keyword here. So to start, we should note that the return type's a little bit different, right? We've got this int kind of thing going on. We're used to seeing maybe just a single int in there, but it's enclosed in parentheses, and these are, or this is a tuple, a value tuple more specifically. And feel free to consult your docs page if you'd like more information on that. Essentially, it's just a really lightweight structure for holding data that you want to work with. Maybe something that doesn't make sense to build a whole class for. You just put it in a tiny data-oriented structure to work with. That's the idea there. So anyways, we'll get into a solution, how we will generate these pairs. To start, I'm going to make a couple local variables here. I'm going to say int low, and that'll start at m, clearly. And then I'll have a current value that I'll sort of increment. So you might see a pattern here, right? We started at the low side and we made it 2, 2. And then we sort of bumped the second value, right? And we keep bumping that second value until it hits the max. And once it does, then you increment the first value, right? It went up to 3. And the min also, the second value also starts at the new value 3, right? Because if you use 2 again, it's sort of like the same pair as this. So that's the pattern they gave us, so that's what I'm going with. And then you see the second value gets incremented until it can't be incremented anymore. And then finally that first value is bumped up to 4, and it matched with the 4, and then we're done. So there's kind of a pattern there, and I'm going to make these variables to help me keep track of when I need to bump certain values up. So to start, I'll also set current equal to m. The idea being that we'll sort of generate this first pair here with 2 and 2 if you pretend that m is 2 and n is 4. Okay, very good. Next, we'll create a loop. And last time we had an infinite loop, but here clearly that's bad for us, right? We want to stay within the range. We don't want to keep generating pairs endlessly. So for my condition for my while loop, I'll say while low is less than or equal to n. So I'll allow my low value to get up to 4, right? But I won't let it go past 4. That would go outside the range defined. I'll add my curly braces to define the scope of my while loop. Okay, and then once we're inside, what I'm going to do is start by creating my first pair. And we're going to use this yield return syntax that we've been using lately to generate these values and return them one at a time. We recall that with these enumerators, they sort of save where they left off and they resume back again to get the next value from wherever they left off inside the method, whatever line it was executing on. But to start, we'll get that first pair created. And so the way you can do this, I mentioned it was a value tuple. So if you want, you can write it out like it's a value tuple, and it's got this create method you can use. And I'll specify the generic types we're working with. And then I can say low and current, right? They're both 2 the first time through here. When I first get into my while loop, this will return the pair 2, 2. And then obviously we're going to have to update those variables so we're not always returning 2, 2. So should be clear, right? We're going to want to bump current to get 2, 3 next, right? The next time through it'll be 2 and 3. So this mostly works, but then you can imagine we get to a situation where if we're not careful, current gets higher than it should, right? We wouldn't want it to go, for example, after 2, 4 to make a pair that said 2, 5. So we got to handle this case where current sort of overflows, if you will. So I'll say if current is greater than n, which is the highest value, right? We're going to have to reset it. So what do we do when that happens? You can imagine it just returned 2, 4, let's say. We're at that point. It bumps current up to 5. And then we check and we say if current is greater than n, which it will be, 5 is greater than 4. What do we do? Well, in that case, we know our first one, the low, we're going to bump up, right? So we can say increment low. And then additionally, let's lower the current value to match that, right? Because low bumped from 2 to 3, and then we're going to say current also equals 3. Remember, after this line, low is now 3, so it's going to assign 3 to both of those. And then when it comes back to the top of the loop, 3 is clearly lower, less than or equal to 4. We're going to come in and we're going to create a pair where low and current are both 3. Nice, that's what we wanted to come next. It's going to bump current. Current will go up to 4. Current is not, 4 is not greater than 4, so it'll skip this, come back to the top. We'll get back in and we'll make the pair 3, 4. It'll bump current again to 5, right? And then we're going to have a problem where it's greater. And then we sort of update again where low goes up to 4, current gets set to 4. You generate the pair 4, 4 next time through, and it'll complete after that. So hopefully that helps kind of walking through that. And if you want to do that on your side, just go ahead and add those console write line statements. You can watch your program executing. And we hit green, which is great. And good, we passed the whole challenge. So yeah, I think that was pretty clear from stepping through this example how that works. Remember, yield return works a little bit differently. It will return your value, but your method is not over yet. So whatever else needs to happen will happen. That your state will resume, and then it will kick you right back here for the next time, and you'll just keep executing, like almost like this thing never left. And in some applications that's useful because you could imagine imagine this was a very intense operation you were doing, or time consuming, I should say, right? And it's like you can't just dedicate a minute to running some long process, right? Like if you have a user interface and you're trying to generate this huge sequence, or in the one case we saw an infinite sequence, you're not going to be able to get any other work done, right? So this kind of gives you a way to step out, do some other work, maybe refresh a UI or whatnot, and then come back and get the next value that you need. It just gives you that nice little break where you can kind of do some work on the side too. So in case you were wondering, like, why did people even bother with this trash at all? You know, it's actually can be very useful. So I think I'll leave it at that. One thing I suppose we could note is I think this will work. I don't think you have to specify the generic types here. I think it can infer that, but we'll test it. And yep, it's still good. And then I think you can even just get rid of this altogether. Let's see if that goes. All right, yeah, still good. I liked the other one because it's a little more expressive. You know, if I just typed out the parentheses and values, you know, you might be thinking, whoa, what's that weird thing you're doing? And hopefully this makes it kind of more obvious where I got this from. You know what I mean? And then you can look up value tuple. You can contrast that with the tuple type as well. I don't want to get into other topics on this video, but you may have seen tuples before, and it's the same kind of idea. The difference being that tuples are reference type and value tuple is a value type, appropriately named value tuple, right? Because it's a value type. And so again, not to go too deep, but this is a concept you should start introducing yourself to, the difference between a value type and a reference type. So do a little reading about that. It's going to help you. It's a really big deal. And I remember when I was learning how to code, it was something that I obviously didn't know when I first started, but that was happening behind the scenes and it mattered. And, you know, it was a source of confusion when I didn't know it and would run into trouble and didn't understand why programs were operating the way they were. So it's a good investment. I found this description on the documents page. It notes it's for Visual Basic, but don't worry, the idea is the same. Reference types store references to their data, while variables of value types directly contain their data. So you can think of it like with these reference types, that's your classes, right? Your custom types and stuff like that. They're generally bigger in size. And so what they do, instead of you can imagine you can pass these reference types around to methods and whatnot in your program, just like you do the value types. But imagine if you had to pass all of the data. Imagine you had some really big, complicated class with a whole bunch of data, and you had to pass that monster onto the call stack to execute a method and pass it to another method, which calls another method, right? And you've got this huge size you're dealing with, and it's very cumbersome and wasteful, and well, you can run out of memory on the stack if you're not careful. So the idea with these references is instead they store a number representing the memory location where the data is contained. So if you have that, that's enough. You can pass that really lightweight integer value around, and then when you need actual data from the reference type, you can sort of dereference it. You go to that spot where it starts in memory. You know how much memory is occupied because of the class definition, and you know this is all happening for you. You don't have to worry about any of this, but you can access the data then that you need. So I guess I'll leave it at that. This will definitely come up more in later videos, or if you want a video on this, we can do that too. Yeah, I'll leave it at that for now. I don't want to go long on this. So we'll go ahead and submit. Yeah, I'll do it this way with the value tuple create, everything kind of spelled out there. I'll submit mine that way. I'm gonna make this attempt again because I changed the code. Submit, get those points, and yeah, let's go ahead and see what other people did. That looks a lot like, oh, that's why it looks like what we did. That's me. So yeah, kind of a nested loop there. Yeah, very good. Same kind of idea there. Nested loops look very popular. So yeah, hit me up in the comments as needed. Show me your solutions. Otherwise, we will keep rolling. Thank you for watching.